Okay, chapter 12 review. I'm going to walk you through how I do these, and yeah, that's it. Okay, so looking at the first problem, identify the sequence as arithmetic, geometric, or neither. So I'm going to do that first. Looking at this, almost always when it's a fraction, see on top it's going 3, 5, 7, 9, 2, 3, 4, 5. That would be a neither. Here, I don't think I'm not multiplying by 9, so I must be adding 8, adding 8, adding 8. That's arithmetic. And multiplying by 4 each time, geometric. From there, I'm going to go to, then it says write the next term. So if I can look at this pattern and know the next term is going to be 11 over 6. The next term I was adding 8, so 25 plus 8, and I get 33. Next one, I'm multiplying by 4 each time, so 192 times 4, and I get 768. Last part was writing the rule for the nth term. That means you can find any term you want. Well, when it's neither, you're not going to write a rule. For arithmetic, you're going to go to your arithmetic formula, which you should have on your green card. Your arithmetic formula is a1 plus n minus 1 times my common difference. My first term is 1 plus n minus 1 times my common difference. I'm adding 8 each time. Now I do some distributing. 1 plus 8n minus 8. So my formula is 8n minus 7. For geometric, again, on your green card, you should have your geometric formula. My geometric formula is a1 r to the power of n minus 1. This one's nice and easy. All I do is plug my stuff in. First term is 3. Ratio is 4 to the power of n minus 1. Number 2 says an arithmetic sequence has first term -4 and common difference of 5. Write a formula for the nth term, then find the value of the 10th term. So my formula, remember arithmetic, so I'm using an equals a1 plus n minus 1 times my common difference. And they gave me my first term plus n minus 1 and my common difference, 5. So now I distribute and simplify. So when you do that, you should get 5n minus 9. For my 10th term, all I'm doing is plugging in 10. 5 times 10, 50, minus 9, gives me 41. Next one's geometric. Geometric sequence, first term and ratio. So for my formula, it's super easy. Remember, it's first term times my ratio to the power of n minus 1. To plug in my 10th term, I'm going to use my calculator. I'm going to plug in, I'm going to plug in 0.3 to the power of 10 minus 1, which would be 9, times by 12. And I get 2.36 times 10 to the -4, so it's a really small number. Write the series in summation notation. You guys had a hard time with these. So let's first figure out if it's arithmetic or geometric. So it looks like I could be adding 5 or multiplying by 2. Well, it looks like I'm multiplying by 2, so it's geometric. This one must be arithmetic. I'm adding 7, so arithmetic. So to write my formula for geometric, I need this. It always starts at n equals 1. That dot, dot, dot means it goes on forever. That's infinity. And then my formula is just like this one. First term, ratio. So first term is 5, ratio is 2 to the power of n minus 1. Second one is arithmetic. So again, I got my sigma, always starts at 1. And this one, how many terms am I adding up? We got 1, 2, 3, 4, 5, 6. So we're adding up the first 6 terms. For arithmetic, I need to take the formula from up here, this formula, and simplify it. So first term plus n minus 1 times my common difference. Distribute 2 plus 7n minus 7. So it would be 7n minus 5. Find the sum of each series if it exists. Okay, We've got a couple different things happening here. Sometimes that sum is not going to exist. If you were here, I gave you this thing yesterday. At first it asks me, what kind of series is it? So looking at this thing, 3i minus 2, what form is that in? That is arithmetic. So if I'm looking at arithmetic, go to this formula. So my sum formula is n over 2, a1 plus an. That's what it is for arithmetic always. In this case, n is 26, I'm adding up 1 through 26, so 26 over 2. My first term, if I plug in 1, 3 minus 2 gives me 1, plus my last term, when I plug in 26, 3 times 26 minus 2 gives me 76. So then when I plug that into my calculator, my sum I should get is 1,001. Let's look at the next one. That looks like geometric. So in here it says geometric. Okay, is it infinite or finite? Well, we're going from 1 to 7, so that is finite, which means I'm using that formula. So a1, and then we have 1 minus r to the power of n. That formula. So I'm going to fill in stuff. My first term is 18. 1 minus 1/3, 1 minus 1/3 to the power of 7, because I'm going from 1 to 7. So then in my calculator, let's do this. I'm going to do 1 minus 1/3 to the power of 7. Take that and divide it by 1 minus 1/3. And then multiply by my number on the outside, which was 18. And I get 26.98. Got more sums on this side. Whoops, here we go. What kind is that? That is geometric. So geometric, is it infinite or finite? We got infinity on the top. Ratio, is it bigger than 1 or smaller than 1? Well, 5 over 3 is definitely bigger than 1. So if it's bigger than 1, does not exist. Next one is geometric as well. We got infinity on the top again. Was my ratio bigger than 1 or less than 1? 2/3 is less than 1. So I'm going for that sum formula. First term divided by 1 minus my ratio. First term is 4. Ratio is negative 2/3. And then plug that into my calculator. 4 divided by something like that. And I get 2.4. Ooh, next one is not in summation notation, but we can still figure it out. Well, what's my pattern here? It looks like I'm adding 4, so that's going to be arithmetic. Arithmetic. For arithmetic, it's n over 2, my first term plus my last term. So, we don't know how many we're adding up, but we have our first term and we have our last term. To figure out the n value, I use my last term and my first term, and I go to my formula for setting that up. So an equals a1 plus n minus 1 times my common difference, that formula. My last term is 113, my first term is negative 3, I'm looking for n, my difference was adding 4. So now I solve this and figure out that n here is my 30th term. That's my 30th. So it's going to be 30. So then I plug this into my calculator, and hopefully when you do that, you get 1650. Last one. We're definitely not subtracting, so it looks like we're dividing. So 20 divided by 8 gives me 2.5. 8 divided by 2.5 gives me this. So I'm dividing by 2.5. Dividing by, what is that one? Did I do that right? No, I didn't. I'm dividing, not 2.5. I'm dividing by, so if I do 8 divided by 20, I'm dividing by 0.4. 0.4 is a fraction. If I look at it as a fraction here, I'm multiplying by 5 on the bottom, so it's 5, 2 over 5. So for geometric, because I'm multiplying, and that means it's going on to infinity, I use first term over 1 minus ratio. First term is 20 over 1 minus 2/5. And when you do that, you should get 33.3 repeating. A bouncing ball is dropped from a height of 20 feet. Each bounce is 75% of the previous bounce. How far will the ball have traveled when it comes to a stop? So, is this arithmetic or geometric? The ball is bouncing. Each time it gets lower and lower to the ground by 75%. That's geometric because I'm multiplying by 75% each time. So, how far will the ball travel when it comes to a rest? So, until it stops. Well, it's going to take infinity for it to stop. So, we're talking about an infinite geometric, like this one up here. So sum is a1 over 1 minus r. So my first term, it's dropping from 20 feet. My ratio is 0.75. And then you plug that into your calculator. You should get 80. So the ball is traveling 80 feet before that thing stops. Given the recursive rule, write the first 4 terms. 1, 2, 3, 4. So it gives me my first term is 9. From there, I take my previous term plus 7. So my previous term is 9 plus 7, 16. 16 plus 7, 23. 23 plus 7, 30. 1, 2, 3, 4. 0.25 is my first term. I do negative 2 times 0.25 gives me negative 0.5. Negative 2 times negative 0.5 gives me positive 1. Negative 2. Last one is the special one, 3, 4. So it gives me my first term and my second term. This term, I'm going to do 3 times my previous, 5, minus 2 times the one back, 4. 15 minus 8 gives me 7. For this one, I'm doing 3 times the previous one, 7, minus 2 times the one back, 5. 21 minus 10, 11. A town's population increases at a rate of 2% per year. In 1990, the town had a population of 15,000. Write a rule for the town's population. Well, we're talking geometric because it's increasing. So it's increasing 2%. So that's going to be 1.02 because I'm keeping my 100% of the people and adding 2% more. So that's my ratio. My first term is 15,000. So 15,000, 1.02 to the power of n minus 1. Bill plans to donate $50 to a local charity, plus $2 for each like he gets on Facebook. Write an explicit formula to determine how much money Bill will donate if he receives n likes. Then find out how much Bill will donate if he gets 70 likes. Okay. So this is arithmetic because it's $2 per like plus $50. So my formula here, n equals my first term plus n minus 1 times my common difference. So I'm already donating $50 for sure, plus n minus 1 times $2 per like. It's going up. So I'm going to distribute 50 plus 2n minus 2. So my formula is 2n plus 48. The total donation, if you get 70 likes, I'm going to plug in 70. 2 times 70 plus 48. He's going to donate $188. There you go.